Hello. Today we're gonna talk about the astable multivibrator using two NPN transistors. So I have taken these schematics and the explanations that go with it from a book called Practical Electronics for Inventors by Paul Scherz and Simon Monk. I highly recommend this book. Okay, so the astable multivibrator, so you have a battery source, the VCC at the top, 6 volts, and you basically have two outputs, V1 and V2. So you have V1 and V2. And yeah, so the output is gonna be a square wave, basically. Ideally a square wave. So let's see how the thing works. So I'm gonna follow the explanation that Paul Scherz and Simon Monk give in their book, and if it's not super clear, I'll go into details of why that is true. Okay, so let's get started. So what they're saying is that when Q1, so transistor Q1, the one on the left, is off, when Q1, this one, is off, its collector voltage, so the collector voltage is here, that's the collector, that's the collector, that's the emitter, and that's the base, of course. So we are interested at the collector. So when Q1 is off, its collector voltage rises toward VCC. VCC is here, so that's this guy, the battery. And so as this occurs, plate A, so plate A here of the capacitor C1, plate A, it's directly connected to the collector of Q1, so of course it's gonna have the same voltage. So plate A of capacitor C1 rises toward VCC. Okay, so when Q1 is off. So when Q1 is off, it basically means that there is a open circuit here. Here, there's an open circuit. This connection doesn't exist. So the VCC, there's also VCC here. So here there's 6 volt. Okay, because there's no current, so there's no voltage drop. So here it's 6 volt, and here it's also 6 volt when Q1 is off. When Q1 is off. So of course, the voltage at the collector, which is the same as the voltage at plate A of C1, is gonna rise. So the capacitor is gonna start charging. So it's gonna rise toward 6 volt. Now, if you look at capacitor C1 and the other plate, so plate B, which is here, okay, which is here. Okay, so, and you assume, so right now I'm assuming that Q1 is off. So Q1 is off and Q2 is on. So it's Q2 is conducting, which means that here at the base you have 0.6 volt. Okay, so this is the base, collector, emitter. So this is, by the way, a common emitter circuit, but this is Q2. So you have 0.6 volt because Q2 is on. So here you have 0.6 volt. Okay, so if you look at capacitor C1, plate A is gonna reach 6 volt, and plate B is at 0.6 volt. Okay, so I think for now, up to now, it's pretty clear. So yeah, so the voltage across C1 is 6 volt. So the voltage, so VAB across is 6 minus 0.6 equal 5.4. Okay. Okay, so let me get rid of all this stuff. We don't need this. Let's get rid of this. Get rid of this. Get rid of this. Get rid of this. Let's 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 get rid of this and of this. So at this point we are here. 6 volt, 0.6 volt, 0.6 volt. So as I said, at this point Q1 is off, Q2 is on. Now at some point Q1 is gonna be at some point Q1 is gonna switch on. You have to go through the whole cycle to understand why it goes on, but let's assume it goes on. So the instant Q1 turns on, what happens is that, you know, before, while Q1 was off, it was like an open circuit, so there was no connection here. But now when Q1 turns on, it's like there is a short circuit. So you have a connection here. So here of course is the ground, 0 volt. So this becomes 0 volt here. And of course the plate goes from 6 volt. The plate A goes from 6 volt to 0 volt. So this guy cannot stay at 0.6 volt, okay, because you have the 0 volt, so it has to drop by 6 volt as well. So this one has to drop by 6 volt. So it has to go to minus 5.4 volt. Okay, so because this one, all those voltages are relative to each other. So if this one drops because of this, because of the short circuit to ground, this guy, which was at 6 volt, drops to 0 volt. So this one has to drop by 6 volt as well. So he goes from, it was at 0.6, so minus 6. That gives you minus 5.4. So it has minus 5.4, meaning that the 0.6 volt here, this also goes to minus at the base, minus 5.4 volt. So the base is at minus 5.4 volt, which means that it's gonna turn Q2 off immediately. So Q2 is not on. So that's how you turn off the transistor. Q2 is now off. Q2 is now off. By the way, in the book, there's a mistake. They're saying that the instant Q1 switches on, plate A of C1 falls to 0.6 volt. It's not true, it falls to 0 volt. Okay? So here, this plate A of C1, it drops to 0 volt, 0 volt, not 0.6, 0 volt. And instantaneously, plate B drops to minus 5.4 volt. Okay, so it's that 6 volt drop. Okay, so let's move on. Okay, so Q2 is now off. So what happens at this point? What happens at this point? At this point, okay, let me read what those guys are saying. They're saying that C1 now begins to charge in the opposite direction via R3 toward the plus 6 volt supply rail. And Q2's base voltage increases toward VCC with a time constant C1 R3. Yeah, so what happens is that if you look, so here you have the ground, so this is ground actually now. So if you only look at this circuit, I'm going to show the circuit. This circuit. This circuit. Okay. So here, and this one, this thing here is connected to ground. Okay, so if you only look at this circuit, you can see that the plate A of C1 is clamped at 0 volt, and plate B, which is currently at minus 5.4 volts, is connected to VCC at 6.0 volt via R3. So it's going to charge. Okay, so it's going to charge, and it's going to go to so it's going to charge, and it's going to go to up to 0.6 volts. So here, this, okay, let me redo this. So this is connected here. So this is going to go to 0.6 volt. 0.6 volt. Okay, so this means that the base of Q2 is going to reach 0.6 volts. And what does that mean? It means that Q2 is going to turn on. So the off here, Q2 is going to turn on. Okay, so now let me get rid of some of that stuff. Because we need to pedal back a little bit to see what's going on with the other one, the other capacitor C2. Let me get rid of all this stuff. Alright. So now we're going to look at what happens when Q1 was on and Q2 was off. So Q1 was on, so it's like short circuit here. So here it's on, so here you have 0.6. So this is the base of Q1. So it's conducting, so you have a correct forward bias, 0.6, Q1 on. So here it means that C2, this plate, so I'm going to call it the B plate, like a mirror image. So here you have 0.6 and Q2 off means this is open. So plate A of C2 reached, C2 was charging and it reached 6 volt, 6.0, 6.0. Okay, so again, it's the same as what happened to Q1. So so this is the collector of Q2, base emitter. So the voltage at the collector rises to 6 to VCC, and since the voltage at plate A of C2 is the same as the collector, this one is also rising toward 6, and at some point it reaches the 6. So on plate A you have 6 volt, and on plate B you have 0.6 volt, and the 0.6 volt comes from the voltage at the base of Q1, which is on conducting. So it means that you have the forward bias. So 0.6 volt or 0.7. I use 0.6 because they use 0.6. Okay, so this is what we already saw when we looked at the capacitor C1. It is the same thing. So the instant Q2 switch is on, and now we know how this happens. So when Q2 switch is on, so this not true anymore. So now you have a short circuit, meaning that the collector becomes grounded basically. So you have 0 volt. So here you have 0 volt at the collector, 0 volt. 0 volt at the collector means that you have 0 volt at plate A. So 0 volt here. So you have a drop of 6 volt. So it means that 0.6 must be dropped by 6 volt. So it has to become 5.4 minus. Okay. So the voltage at plate B of C2 is now minus 5.4, which means that the voltage at the base of Q1 is also 5.4. And what does that mean? Is that now Q1 is cut off. It doesn't work anymore. So Q1 doesn't conduct. So Q1 is actually off. Q1 is off. So this not true, and this it's open circuit now. Okay. So now we have this, and the same thing happens as before, but now we are looking at the mirror circuit. What's going to happen is that C2 is going to charge. Okay, so let's look at this. Okay, so if you look at this circuit, okay, so here you have 6 volt, And here you are connected to ground. So you have 0 volts. So plate A of C2 is clamped at 0 volt. So what's gonna happen is that the plate B of C2 is gonna charge. So the minus 5, so it's gonna go from, so B of C2, it starts at minus 5.4, it's gonna go up to 0.6. So it's gonna go to 0.6, 0.6, meaning that this is 0.6. So the base of Q1 is now at 0.6, which is the forward bias that it needs to turn on. So now Q1 turns on. Okay, so it's the mirror image of what we had earlier. Okay, so it's exactly the same thing. Okay, so now what would be interesting to do is to look at the voltage. Look at the voltage on plate A and plate B of C1 as time goes on. So what you can do is you could put like an oscilloscope probe on A and B and see what you get, or you can use LT Spice and see and look at like a time domain plot. But I can do it here. We can do it here. So let's create a new page. Okay, so let's do an axis. Not the greatest, but that's T. And here we have the voltage. So this is 0. And I'm going to put 0.6 volt here. I'm going to put 6 volt at the top. And I'm going to put a minus 5.4. And now I'm going to plot. Let me plot. So I'm going to plot C1 plate A. C1 plate A, which happens to be the output on the left side. So this is how it looks like, the voltage. So this is 0, so it goes like this, 0. Then you're going to have the charging. It's going to look like this. Then it drops. 0. Another charging. It's not very good, but you get the idea. And drops. And 0. So this is C1 plate A. Now you can also plot C1 plate B. C1 plate B. And look at what it looks like. So it looks like this. It's at 0.6, 0.6, then it drops to minus 5.4. It drops to minus 5.4 and then you have a charging. So it charges up to here, 0.6, okay? Then it stays at, oh, hold on. Oh no. Let me fix that. Okay, so let's go back to that. So it stays at 0.6. It's not better. So it stays at point. So it's here. It stays at 0.6. Okay, so it's like here. So here, if I want to show the rest, it's kind of like that. Okay. So it stays at 0.6 and then boom, it drops to minus. Okay, and then it charges towards 0.6, stays at 0.6 and drops. So this is what the voltages look like on each side of C1. Same idea for C2. Okay, so I think I'm gonna stop here. As you can see, I mean, even this circuit, which is pretty simple, it's not that obvious to understand what goes on. Okay, so that's why I'm saying electronics, it ain't that easy. I mean, it's a bit challenging. Okay, so I'm gonna stop, as I said. So I'm gonna stop here. If you like this kind of content, please like, comment, subscribe. It's gonna give me the motivation to make more. Yeah, so I will try to make more videos. I don't know. It depends if people are interested. If nobody's interested, I don't think I'm gonna do more. Alright, so I'll see you around. Bye.